Okay, so this is the number 10 on the 2023 state test team run, and we are given a triangle ABC. Okay, so the right angle, and then that's why A is 90 degrees, and we are constructing three equilateral triangle on each side of the right triangle, and then by taking one of those like points in each equilateral triangle, we make another triangle which is DEF, and the area of that DEF is given. So what we want is the hypotenuse. So it is clear what we are looking, but at the same time, it's not obvious how actually can we kind of go from there. So, we do know the leg, but we don't know anything about AC, and then BC is what we want. Area of this DEF is given. So we have to somehow like relate those info, okay? So what I'll try is the chord bash and then do something from there. But if you have something better than this, please let me know. So I like to see if there's a way better approach than this one. But well, okay, so I'm gonna take this as the origin. And then since this is a equilateral triangle and I just need to know the coordinates of this E and D, so I'll just take the E's like AC as 2A units because that will make my numbers like whole number. So since I just need to know that distance and stuff, so let's go ahead and write these. So this is 90 degrees, and I just need to know the coordinates because if I kind of find the coordinates of D, E, and F, maybe I can go with the shoelace approach. That will be my approach actually in this case. So if I name this is A, since this is equilateral triangle, so this part H to C is also A. That is something. And if I do the same thing with the other ones, right? So if I connect this to a midpoint of AB, and then same thing, we can do this right there because, if you drop the altitude, since this is a equilateral triangle, that will be perpendicular. So that's going to be perpendicular bisector as well. So let's go ahead and do that. The reason I'm just doing this because it's kind of easier to find the coordinates of those D, E, and F because there is a 36 to 90 going on. So like, let's start with this guy. So, this is a unit, and I just start the like point A as the origin, so which is 0, 0, right? Since I move A units to the right, if A is a positive number, so the E has A as the x coordinate, but the y coordinate is just this distance because if you extend this as y coordinate, you can see that maybe I should make it a bit obvious. So give me let's try this. So if I draw this as my x-axis and then this is y-axis basically. So now we have the coordinates, right? So this is the y, and then this is x. So like now I need to know this distance. This is 60 degrees, this is 30 degrees, and then 30 degrees opposite to 8, and that means this distance has to be 8 times root 3 in terms of the length of this part, which means the y coordinate, which is going to be the same as this distance. Okay, so it should be just the negative version of that number because that is the coordinate. And if I use the same idea, so this is 1 unit, and then this is 1 unit, which is basically one unit above that origin. The y coordinates of this is like 1, but the x coordinates is this distance. So if I see this is 30 degrees and this is 60, 30 is opposite to 1. So that means this is going to be root 3 because of the special triangle. So the point D has to be, since this is to the left of 0, 0, I will go with negative root 3, comma 1. So that is my other point. So these two like wasn't too bad so far, but finding the coordinates of F is a bit kind of challenging, I guess, because we don't really have nice horizontal or vertical stuff going on here. So what we can do instead, we know there is a triangle right here, which is a right triangle. So if I can relate like either FC or this distance with the size of the right triangle, maybe I can kind of use the similar figures and go from there. But it doesn't look like we have a right similar triangles either. So which is why we have to kind of make it. But while we are trying to make it, we just need to make sure there will be some similar triangles. So I'm going to just draw a horizontal line from that 90-degree, the vertex, which is at the same time midpoint of BC, because this is perpendicular bisector at the same time. Okay, so like, why do I need this? Because if I do, actually drop the other one as well. So if I drop the altitude from F to this horizontal segment, so it will be something like this. And I don't really know where this is going to be touching. It could be somewhere right here, maybe to the left, but it doesn't really matter. So what I just need is the coordinates of the F point, okay? So after this, this is the horizontal, this is vertical. And I just like to see if we have something nice angles that is congruent. So if you look at this angle right here, okay, and that is the same as the angle right here, because we draw two, like we draw this line in a way that that will be parallel to this axis. That's why these two are alternate interior. And I do know this is 90, which means this blue angle and this angle add up to 90, but at the same time, this blue angle and this part of B is also add up to 90 because that's part of the equilateral right triangle. So for that reason, I can go ahead and kind of shade this piece as maybe yellow. So then this angle, the yellow one is going to be same as this one because these two is add up to 90, these add up to 90. So then the last one that we are actually looking for, this is like these two, blue and yellow add up to 90, but this is also a right triangle. And then one angle is yellow, so this second angle, which is going to be this part, has to be blue. Okay, so now we know that this triangle and this triangle are similar, which is actually nicer. But at the same time, we don't know this segment, we don't know this segment. That is actually what we need. But we do actually can find this segment because I know the BC somehow like a hypotenuse, right? So then I'll just go ahead and label them. So let's say the hypotenuse as, let's say this is the C units, and then this is C unit, just to make a whole number. And since this is also 30, 60, 90, so that means this is C times √3 for this hypotenuse of this triangle, okay? So now let's write the ratio. So if I want to go with the hypotenuse C √3 of this triangle, divided by hypotenuse of this triangle, which is 2 times C, is equal to, I just didn't want to write the similarity statements, but it's obvious that we have this triangle and this triangle are similar by angle. So you can just skip that step. And now this leg, I'm going to call this is X unit. So this piece. And then this leg, I'm going to call this is Y unit. So the X over, so the X is opposite the blue angle. Blue angle is opposite to 2 units. So that should be 2 equals Y over 2A. So if I take the first two, like if I, so this equation, the 2's will cancel and then C's will cancel. X equals just √3. And then if I take the first and the last one, you know, C's already canceled and the 2's will cancel. Y would be A times √3, which is good because those are not bad numbers, variables. So what we are going to do now, since we know this coordinate is just the middle of the BC, that is actually like the x coordinates of this point is going to be half of this AC as well, which is the A unit from the origin. So that was actually A comma 1 because this was 1. So this is A comma 1. So we know x is equal to √3, which means you move √3 units from this point to here to get the x coordinates of this f, so which is going to be A plus √3. So that's the x coordinates. And the y value was 1 right here. So you move y unit, which is A √3. So the y coordinates should be 1 plus A √3. So it looks a bit messy, but I think it's not too bad for number 10. And now at the end, you know, we have all three coordinates. So I just want to use the shoelace now. But to use the shoelace, we kind of need to start with a nice one if possible. So I think the best one of those coordinates is not the F. I think the best one is choosing this guy because we're going to write this twice. So you will get negative √3 comma 1. And if I go with this one or that one, which it doesn't matter, I guess, I'll go with this one. So the a plus root 3 and comma 1 plus a root 3. And the last point, I will say a and minus a root 3. Okay, so since we start with this, I'm going to write this one more time and this one. So for those of you who don't really know the shoelace, I think this step is going to be a bit different. So we just multiply these guys crossly, and then we're going to add those values, which I should do that. So I will go with the right here. So 1 times these two, which is going to be a plus root 3. And then a times this will be a plus a squared root 3. I multiply this by this, and then multiply this by this. 2 negatives will be positive, so you will get root 3 times a root 3, which is 3a. So we do have these guys from the left side, and then we just multiply the other way around as well. So we multiply these, and then these. That's since this is going to look like I guess shoelace, that's why it's named that way. So you multiply these, 1 plus a root 3 times this. I'm going to have a minus. And then that will be minus root 3 minus 3a. And then for the second one, this time this will be negative a squared root 3. And then if you multiply this by this, that will be 3a, but negative 3a. And then the last one is just a. So if you subtract this, and you will need to take the absolute value as well. So we will take the absolute value of this whole thing, which will be a nice number anyway. So not too nice, but so this is going to be equal to 1/2 of this will be equal to the area. So if you multiply both sides by 2, you will get 46 root 3. So, and if I'm going to skip the middle steps, but if you solve this equation, you will actually end up getting a quadratic expression. And if you use the quadratic formula, then you are going to get a as 2 root 3. So as soon as you have the a as 2 root 3, we just need to make sure we answer the question because we were looking for the hypotenuse. So this leg will be now 4 root 3. This is 2, so square of this will be 48. Square will be 4, and add up to 52. If you take a square root, so you will get 2 root 13. So again, this is not too easy problem, but at the same time, we use a lot of kind of topics in this case, since this is meant to be the most challenging problem on the test, which is actually the case. Again, if you have any other approaches, maybe better approach other than using the trig and stuff, so share with us. So I will see if you have something better than this. Okay, I'll see you in the next video.